Okay. So this is exam 2 review. So the first question in your homework or in your review is pretty straightforward. It says find the exact value of the expression. Square root 2 over 2. Now, there's not much to do here because it's technically on the circle, but you can apply the definition. Remember that if you use the definition, this is saying that sine of theta is equal to square root 2 over 2. So which angle gives me a y value of square root 2 over 2? Yeah, so theta will be pi over 4. So there's not really much to do. I mean, you could use inverses or you could use a definition and just look at your circle. Okay, so let me show you the exam. Questions. There you go, looks better. Okay, so sine inverse of square root 2 over 2. Exact value would be pi over 4. There's not much to do here. Here, you literally just plug it into your calculator. Let's see if I hit the answers. Yeah, there it is. So for this one, I don't really expect much work here. Just give me pi 4, so show me the step that I show. That's good enough for me. You know, there's not much to do. Number 2, it literally just says plug in your calculator. So notice how none of these have degree symbols, so you should assume it's in radians. So we'll skip 2 because literally you just plug it in. Okay, let's see here. 3 and 4. 4 looks like it's challenging. Do you remember when we did one of these in the examples? Given a function, can you find the inverse? So similar to what we did back in pre-cal, or sorry, college algebra. Let me write the instructions.
Sir?
Yes.
I think it froze.
What happened?
Oh, I think the thing froze for a second. It was weird. I don't know if that's you or me.
Oh, I don't know. Anyone else having issues or? Just let me know if anything happens. I'll stop downloading movies. I'm just kidding. Let's see here. Find the inverse function f inverse of the function f. So here's f. Find cosine x plus 9. Remember how we said step 1 was changes to y, right? So we get y equal to 5 cosine x plus 9. Step 2, we said switch x and y. right? So that will be x equal to 5 cosine y plus 9. Solve for y. So here we just do algebra. This will isolate the cosine and then introduce inverse cosine. Okay. So that'll be x equal to so actually let's start. Well, let me just start from here. So first step is subtract 9 on both sides. So that would be x minus 9 equal to 5 cosine y. Next step, we'll go ahead and show extra steps today with the algebra. Divide both sides by 5. So now I've isolated cosine, and it's equal to this. Right? So then introduce cosine inverse on both sides. So y will be equal to cosine inverse of x minus 9 over 5. Any questions on any of these steps? Okay, so not too bad, right? So here it is. And that's what we found. Let's see here, number 5. Okay.
Oh wait, sir. I'm sorry. I was looking at how it's written up there. Okay.
The question?
Yeah. So it's F. F. Basically, I was looking at how it's written on the thing.
Yeah, it's just f. This means f inverse of the function. That's a -1.
Okay.
Well, let's
Got
do.
it.
Uh-huh. You guys cool on this page?
So far.
Okay. So number 5. Find the exact solution of the equation. For cosine inverse of x equals to pi. Okay, so for this question, I'd say divide by 4 as the first starting point. cosine inverse of x is equal to pi over 4, right? If I were to do cosine of both sides, we know that these would cancel, making this x equal to cosine of pi over 4, which on the unit circle is square root 2 over 2, which is the answer is B. Any questions on 5? Is that clear? Move on to 6. 6 seems a little different. Find the exact value of tangent inverse of cosine inverse of negative half. So remember here we said we have to use the triangle. So you say basically that theta be cosine inverse of negative half. So tangent, actually that should be just a regular tan, not inverse. So tangent of cosine inverse of negative half will simply be tangent of theta, just to keep it simple, right? And this, by definition, we can apply the inverse definition and say, well, that means there exists a cosine of theta that will give me a negative half, right? So right here, I applied the definition of inverse. Here, I'm just relabeling this as theta. So what they really want to know is this. The actual question is, what is tangent? So now that I have cosine, find tangent. So opposite over adjacent. One of them is negative. If cosine is negative, I'm sorry, it should be adjacent over hypotenuse. That's what confused me. That didn't make any sense. So this would be negative. This will be 2. The hypotenuse is never negative. Okay. All right, so let's find the missing side. So a squared plus b squared equals c squared. Let's call this one b. I want to find a. So a squared is equal to c squared. Subtract that over, that'll be -1. I forgot to plug in c. Sorry about that. So I'm a little distracted today. Oh, so that'd be 4 minus 1. So a will equal the square root of 3. Oh, let me look up the question, make sure there was no other information that I might need. No, I don't think so. Okay. So there's my triangle. So this question right here, remember, it's asking what is tangent. So tangent of the theta is equal to, so they want to know, opposite over adjacent. So square root 3 divided by -1. So this is what they wanted. Okay, so when you see this question, when you see a tangent, and you see two different functions like this, an inverse and then the tangent or something that doesn't match, then you're going to build a triangle and you're going to use the inside as your as some of the pieces for the triangle. And then you use Pythagorean theorem, and then you answer what is tangent. And that's where this came from. Does that make sense? Is there any questions on number 6?
Sir?
Yes.
I'm sorry, sir. Why is the square root of 3 negative?
Oh, so now let me show one extra step for you. So this will be opposite over adjacent, right? Which is square root 3 over -1, which is negative root 3. Right?
Okay, thank you. I just was a little bit lost right there.
Does that make sense?
Yeah.
Any other questions on number 6? Okay. Let's move on to number 7 then. Find the exact value of cosecant of -2. Cosecant inverse. Yeah. So there's a property that says that you can change to the reciprocal. So that is equal to sine inverse of the reciprocal. You just flip the 2 over. The sine and cosecant are reciprocals of each other, but if they're in inverse form, you can still do this. Okay.
Sir, could you like explain that again? I'm sorry.
Yeah, sure. It's just basically saying that sine of theta, and sine inverse of theta is equal to cosecant inverse of 1 over theta. So you just flip over, take the reciprocal of this argument when you go from cosecant to sine. And that's a consequence of sine theta equal to 1 over cosecant, right? So since I know how to deal with sine, I went ahead and changed it using this property. And once we've done that, this ends up a value on the circle, right? Let me grab my calculator. Works better with the light on for some reason. Okay, so negative 0.5 will be in radians. Let's see what that is. Negative 30. So remember that sine inverse is defined, the range is defined between pi over 2 and negative pi over 2. So it's going to give us a negative angle, which is negative pi over 6 in radians. That's why their answer is negative, because of the range of sine inverse. Does that make sense?
Not really.
Do you remember the range and domain of sine inverse? Let's see here, so I can find a picture for you. There we go. Has it all in one place. I don't feel like digging up my notes right now. So sine inverse domain can only be negative 1 to 1. And we chose that because it needed to be 1 to 1 in order to be an inverse. So that restricts the range. So whenever you plug, remember what does the inverse sine do, right? You plug in numbers and it spits out the angle that has that y value. But the angle that it's going to spit out is only going to be within negative pi over 2 and pi over 2. It's not going to go outside of here. Even if the answer is the actual angle somewhere else, you'd have to correct for it, like using a coterminal angle or a reference angle. But the solution here is going to be negative. So if you look at our circle, let's pull up our circle. Where is it? Stupid thing. There it is. So what that means visually is that inverse function, whenever you plug in a number, let's say I plug in 1/2, right? It's going to give me pi thirds, no problem. But if I plug in negative half into sine inverse, it has no choice but to go down here to negative pi over 2. So sine inverse, the range of sine inverse, meaning it can only spit out angles from here to here. So negative pi over 2 to pi over 2. So it has to go in the negative direction. It is not allowed to go over here. Okay. Cosine inverse is defined up top. Tangent inverse is defined over here. Okay, so that's why they gave us negative pi over 6, which is right there, for the negative half. So I went in the negative direction, negative 30 degrees, instead of going all the way around to 330, because that would be outside the range, and that's too big. So I go this way. So that's why this is negative. But if you punch into your calculator, that's another, it's just what it gave us, right? As well. 30 instead of 330. Any other questions on 7? Okay, number 8 is similar. This is use a calculator. Pretty much what we did over here. It's just that we didn't really need to, but you could have. Use a calculator. To find the exact value in radians. So cotangent inverse of 10 over 29 is equal to tangent inverse of 29 over 10. So we can use this one because that's actually on our calculator. Whereas cotangent is not, so I had to switch. So we just go in here, plug in tan inverse of 29 over 10, and you get, oops, it's still in degrees. They said they wanted it in radians. To 1.238 or 1.24, I guess. So 7 and 8 are very similar. It's the same thing. You just punch in your calculator and give them the answer. It's just that this was on the circle. That was the only difference. So you could have used the circle instead. Write the trig expression as an algebraic expression in U, sorry. Expression. Can't even read that. Rewrite it over here. Expression in terms of U. So we do one of these, I remember cosine of sine inverse of U. So similar to that other one we did in number 6. It's the same thing. See how they had they didn't match tangent of cosine inverse. Now we have cosine of sine inverse. Same deal. So first thing you do is let theta equal cosine sine inverse and change that to sine theta equal to U using your definition. Once you've done that, you can build the triangle because opposite, there's an invisible one here at all times, remember, opposite over hypotenuse. Once you do your Pythagorean theorem, this would be 1 minus U squared. So now the question is basically asking, now that I renamed this, what is cosine? So that's going to be adjacent over hypotenuse, right? So there's the adjacent side. And that's it. That's all they want. So they wanted cosine the whole time. Any questions on number 9? Okay. Let's do 10 then. Solve the equation on 0 to 2 pi. Actually, that should be a parentheses there. So the question is 1 minus sine of theta is equal to 1/2. So subtract 1 on both sides and you'll get negative sine theta equal to -1/2. Divide by negative, sine theta is equal to +1/2. So isolate the sine is what you got to do. Once you've done that, you introduce sine inverse on both sides. So then this becomes theta equal to, basically if you use this in your calculator, that'll be 30 degrees. Now remember how we said there's 2 locations because the inverse sine can only give you one of them because it's restricted to the right half of the circle. So this is the first angle. The second angle you find by subtracting from 180 degrees. So the answers will be 30 degrees and 150. Or if it is in radians, that will be pi over 6 and 5 pi over 6. Okay, so we got that guy. We found cosine. And yeah, pi over 6, 5 pi over 6. Any questions on number 10?
Yes.
What's up?
Can you explain how you got rid of that one again at the very top?
The negative?
Yeah, it's 1 plus sine.
It's 1 minus sine.
So yeah, how did you get rid of the 1?
Yeah, let's show our scratch work over here. So basically you'd have this, and you do -1, -1. So then you get negative sine equal to -1/2, because 1/2 minus 1 is -1/2.
Okay.
And then you divide by -1. And you get to here.
Thank you.
Yeah, no worries. Any other questions on number 10?
Yes, sir. I very possibly would look at sine theta equals 1/2 and think I'm like basically done. and then just try to like go off of that. How do you know to go to those next steps?
Well, the question, what we're solving for is theta. But in order to get there, you gotta isolate sine. If you were to stop here, you could use a circle to find these answers technically, because this is an easy value, right?
Yeah.
If you go to the circle, I technically did not need inverse sine, right? It's 1/2 at 30 degrees and it's 1/2 at, where's the y here? 150, right? You can
Yeah.
see it. But I wanted to show you how you do it in general, because what if this is like 0.27, right? That's not on the circle. So you use your calculator to get some number, and then you subtract that number from 180 to get the other angle. So when you get to here, you have to remember or recognize you're looking for theta, right? That's the variable. Solving the equation implies solving for a variable, so it's that guy.
But why did you use the inverse sign again if you could have just done that with the unit circle?
Because the number here could not make, it's possible that it will not be on the circle. I can give you a weirdo number here that's not on the circle.
Okay.
So then you'd have to do it this way. So this method works whether it's one of the pretty numbers or one of the ugly numbers.
Okay.
I just chose to use the pretty one because it, it looks nicer. But let's do the next. The next one is not pretty. So you'll see why it's necessary. Any other questions on 10? You guys cool on this page?
So far.
Alrighty. The next one is 11. Push this pen out. Okay. So here it tells you straight up to do this. Use a calculator to solve the equation on the interval (0 less than or equal to theta less than or equal to 2 pi. Oops, no equal to on the second part. Round to 2 decimal places.
Is that a decimal point in front of the 2 pi?
No, this is a straight mark. So this is 0 less than or equal to theta less than 2 pi. So for this guy, you have to introduce inverse tangent on both sides to cancel tangent. So now theta is equal to this, which is what we were solving for. Now we have to use our calculator because that is not on the circle anywhere. So it appears that it's going to be 1.37, I guess. So the first theta is 1.37. Theta 2, so tangent has a different kind of period. So to find the second one, you have to add by pi. So 1.37 plus pi. that will be 4.51. So our solution set is these two. So this is from the calculator. And once you, when you're doing a tangent, to add a pi to get the other one. So that's how they got this here. So notice how all of them have 1.37 because that's what the calculator gives you. So you need to make sure which one is this, right? By adding pi.
Excuse me, sir.
Mhm.
So you always add or add by pi for a tangent?
Yeah, for tangent.
Okay. Do you ever subtract by pi?
No, I don't think so. I was trying to think of an example where that would happen, but no. Because it would end up being negative. So
Okay.
if you subtract it by pi, well, let's just pretend, right? Let's say we did subtract by pi. This would be negative, and to fix a negative angle, you would have to add 2 pi to it, which would end up getting to here anyway. So yeah, just add pi. Okay, number 12. Solve the equation. On the interval 0 to 2 pi. Cosine squared theta minus 1 equals to 0. Now, we could use an identity here, right? You recognize which one this is?
Pythagorean.
Right? So if I subtract by 1, try to make this look like this. It's almost there. So I'm going to move the sign over here by subtracting sine squared. And then I'm going to subtract in the next step by 1. So cosine squared theta minus 1 is equal to negative sine squared theta. So this is actually negative sine squared theta. So when is sine squared theta equal to 0? If you look at your circle, the sine values are 0 at 0 degrees and pi or 180 degrees. So theta would be 0 and pi. So nothing crazy, right? Does that make sense though? That's how they got this. Okay. Okay, 13 is similar, so I'm going to move on to 14. These is when the proofs begin. Simplify the expression. So here, all they want you to do is do algebra to make it look pretty. We're not solving for anything. So you guys know that the tangent is a ratio of sine over cosine, right? When we change it into that, we see that we have two fractions that you can add together. The LCD of these two fractions is going to be 1 plus sine theta times cosine theta. So get the LCD here, you multiply it by the missing piece. It needs to be like this. So this needs a cosine. This other fraction needs the 1 plus sine. Right? I'm just adding two fractions. They're not pretty, but that's essentially all we are doing here. Is this okay so far before I get into the algebra? Okay. All right then, so cosine times cosine will give us a cosine squared over, I'm just gonna go ahead and leave it like this. Plus multiply that out, that'll give you sine theta plus sine squared theta over the LCD. So I'm just gonna leave it like that. So now they have the same LCD, so I can add the numerators. So that'll be cosine squared theta plus sine theta plus sine squared theta. All right. Now notice that on top you have sine squared theta plus cosine squared theta, right? So we know that this right here is going to be 1. So far, all we've done is add two fractions. This is when the identities start, so that becomes a 1. So from here to here, we use the Pythagorean identity. And the denominator is still there. But notice you can cancel this piece, right? So we have a 1 plus sine theta on top and 1 plus sine theta on the bottom. So this cancels with this, leaving me with 1 over cosine, which is equal to secant. So from here to here, that was the, I think, quotient. No, actually, reciprocal. So this weirdness at the beginning was just a secant the whole time. So that's how we simplified it. Are there any questions on that? Or any of the steps? Is that okay? So that's how they got secant. So you need to, when you're given something like this, just figure out a way how you can simplify them. Usually, if you see a fraction, then you should probably add the fractions and then see what happens. So that's what I did. I added the fraction right at the beginning. So I recognize there's a fraction on the left here, but change the right one to a fraction as well, a ratio. Add them together with an LCD. Once I got here, I noticed cosine squared plus cosine squared will cancel out into a 1 by the Pythagorean. So once I rewrote it just so you could see it better. So this becomes a 1. So there's that 1 there. This sign is right here. 1 plus sine cancels with this 1 plus sine. That was there the whole time, right at the bottom. Those are gone. 1 over cosine is the only thing left, which is a secant. So adding fractions made all this start to come out. Okay, you guys cool on this page? Okay, 15. 15 is similar, except this time you're actually proving something. But the type of work will be similar. So secant theta minus 1 over tangent theta is equal to tangent theta over secant theta plus 1. So you choose a side and you try to get to the other side. So I'm going to choose the left side, I guess. Okay. So right now I don't have any ideas, but when I see something like this, a secant minus 1, if I would have seen a cosine plus 1, sometimes I think, you know what, maybe I should multiply by the conjugate. Multiplying by the conjugate of the denominator. So it's the same thing where you just put a plus sign. That's what conjugate means. Minus 1 plus 1 plus 1. So you do the top and bottom. So the top will turn into the difference of squares. Right? And the tangent will be on the bottom multiplied by that secant theta plus 1. So right here is multiply by the conjugate. So it's one of the techniques. The other technique was just add fractions. This one is try a conjugate and see if it works. Let's hope, right? On the top, do you recognize what formula this is? Right, we said that secant squared theta minus 1 is equal to tangent squared based on your identities. So this top part is the same as a tan squared. So one of these tangents will cancel. Getting us to here, which is where we wanted to go, right? That's what we were trying to show. Any question on the proof? Okay. Let's keep going, I guess.
Oh wait, sir, I'm sorry. I was still writing part of that.
Oh yeah, no rush.
Thank you. Okay, I'm good. Thank you.
So find the exact value of the following tangent of pi over 12. So there is no pi over 12 on your circle, correct? So we can use the half angle to help us out because we know that half of 6 is 12. Sorry, half of 12 is 6. So this allows us to use the half angle formula for tangent. Remember we said tangent of theta over 2 was equal to, I don't remember what it was. Let me look it up. I forgot. There was 2 of them. We'll use this guy, I guess. Sine theta over 1 plus cosine theta. So this would be equal to sine of pi over 6 over 1 plus cosine pi over 6. Using the formula, right? So let's do that over here. Sine of pi over 6 over 1 plus cosine pi over 6. What is sine of pi over 6? It's 1/2, right? 1 plus cosine pi over 6. That will be square root 3 over 2. Now we can use a technique to simplify this complex fraction. Where we can multiply the LCD on the top and bottom to cancel all the fractions. So 2 times a half on the top would be a 1. 2 times both of these, I'll show the work here, be 1 plus square root 3 over 2. Let's see. Right? So these cancel, leaving you with a 1. And the bottom will give me a 2 plus square root 3. Now when you multiply this by this guy, cancels the 2, giving me this. And then 2 times 1 is a 2. Okay. So this guy here, the answer is 2 minus root 3. So we are going to have to rationalize to pick the correct answer. Because right now we have a square root on the bottom. So what you got to do is multiply the top and bottom by the conjugate in order to cancel this kind of radical. So the top part will be 2 plus root 3. The bottom will become a difference of squares. So you'll get 2 squared minus root 3 squared. Four minus 3, which ends up being 2 plus root 3 over 1, which is our answer. At least it should be. Yeah, minus. Yeah, I think it should be a plus. Anyway, do you understand? Do you guys follow the rationalization? Why we had to use this? I mean, technically, this was the answer, right? At the beginning, but we had to rationalize to get rid of the square roots in the bottom. So when you have more than one term with a radical, you have to multiply by this conjugate to cancel the difference of squares. Okay, 17. You guys cool on this page? Okay. 17. Use the information given about the angle theta. So they're saying the angle is between 0 and 2 pi. Well, okay, that's just a general thing. We're solving in that section. Find the exact value of the following. So to give us some info, cosecant theta is equal to 5/3. Then they tell us that theta is between pi over 2 and pi. They want to know, they want us to find cosine of 2 theta. Okay. So we're going to need the formula for double angle, and we need to know what quadrant this is. So where is my double angle? Okay, here it is. There's a couple of them. Cosine to theta is equal to cosine squared theta minus sine squared, which is equal to 2 cosine squared theta minus 1, which is equal to 1 minus 2 sine squared theta. So just pick one, right? But we're gonna need, what quadrant is this though? Pi over 2 to pi. Yeah, it's gonna be second quadrant. Okay. So we need to use the triangle to find to be able to find cosine and sine, right? What is the reciprocal of cosecant? Or what is the definition of cosecant in terms of a triangle? Yeah, so cosecant theta is equal to 1 over sine, which means that sine would be 3/5. So opposite over hypotenuse. When you solve for this angle, you'll get a 4. So sine theta is equal to 3/4. Cosine theta is equal to 4/5. But since we're in quadrant 2, right, this has to be negative. This is negative. The x's are negative there. So now we can answer the question. Cosine of 2 theta is equal to, I'm gonna use the square, I guess. Cosine squared minus sine squared, which will be negative 4/5 squared minus 3/4 squared. That'll be 16/25 minus 9/16. Which is something. See if my calculator can do that. It's out of pure laziness. 9/16. 31/400. Let's see what they got. That's not right. 5/3. Oh shit. Okay. This is supposed to be a 5. So I don't know what went wrong here. It's a 5. This is a 5. 25. 16 minus 9 would be 7/25. That's much prettier. Yeah, that's what they got. So the next one is similar, except they used they used the half angle formula. Remember we did this, I think, last time. Remember how we said you need to figure out where is your theta/2? Is it still in this quadrant? And if it is, then that's when you decide what sign to use. Let's do one of these. So 18, I guess. You guys cool on this page? Or any questions? Let's assume we're good. What number were we at?
Oh, sir, are we doing 18 or 19?
19. Express the product as a sum containing only sines or cosines. So this is the section about product to sum, right? So you use let me look up the formula. Sum, oops. So cosine is going to be formula for this guy. We had alpha cosine beta, which is equal to 1/2 times cosine alpha, oops, minus theta plus cosine alpha plus beta. So this is my alpha and beta. So apply your formula. So cosine of 3 theta cosine 2 theta is equal to 1/2 times cosine of 3 minus 2 plus cosine of 3 plus 2. It'll be cosine of theta plus cosine of 5 theta. So all you do is apply the formula. That's how they got this guy. 20 would be the same. It's just they use a difference. So use the sum to product instead of product to sum. All right, that's all for the review. If you guys have any questions.
You keep that up for a second?
Yeah. Let me choose a date for your exam. Okay. I don't think this much time is necessary, but I'm gonna give you till November 8th at about midnight or so.
I appreciate the extra time.
And just in case, right?
Me too, especially with Halloween coming up.
Yeah,
Yeah.
it's like this is a busy week for me, sir. I have my husband's birthday and our wedding anniversary.
Oh man. Yeah, that's a lot going on.
Yeah,
Yeah, I figured making it on Halloween would be kind of mean. Okay. So you'll have so try to finish up the homework as soon as you can and start preparing for the test. The next probably on, let me see here. On Thursday we'll probably start chapter 8.
I'm sorry. What day did you say you were gonna make the test?
It's officially November 8th at midnight. Okay, we'll stop here and post this in as soon as I can. If you have no questions, you're welcome to head out. And if you want to stick around, that's fine too.
I just want to bother you, honestly.
Have a great night.
Have a good night.
Sir, could you continue doing some of these with me?
Which one would you like to do?
The ones we didn't do. I know it's kind of just me being insecure or whatever, but you know what? Insecurity serves me well sometimes. So I'm just
All
gonna
right.
roll with it. Can we do the ones we didn't do? 3, 13, and 18? 3, 13, 18?
Let me see.
Oh, hey, sir.
Hmm.
I'm super behind on the homework, and I was gonna spend this weekend catching up on it, but I ended up spending this weekend like doing a good deed. Like, there's this girl in my chemistry class who told me during class that she was gonna drop the class, and I'm like, dude, why? And she's like, because I scored like a 30 on the last test, and I'm like, that's horrible. I'll tutor you. And so I spent this weekend tutoring her instead of catching up on my homework because I didn't want her to drop out of the class because that would have fucked up her like her whole thing, you know?
Yeah.
And now I'm all stressed out because I'm behind on math homework, but I helped her, so I'm kind of a good person. So it's like
Was that the chemistry?
yeah, so like doing good things doesn't feel nice. Like being a nice person feels bad.
Well, I mean, sometimes you have to sacrifice to help somebody else.
Yeah. She's kind of punishing me for it too. because she found out I was an atheist, right?
Hmm.
And so after I spent the weekend helping her, she's just sending me Bible quotes, like trying to save me. And I'm like, dude,
Oh man. Yeah,
I'm
I
like, I
mean,
helped you.
I think that's just how they think.
I know. I mean, her heart's in the right place, but the execution is all wrong. Yeah.
That's
So
fun. That's kind of funny, but you can't help but like,
be like, bruh.
yeah.
Like, come on, man. I helped you. Um, anyways, so I'm way behind on the homework and I feel super bad about it. And
Hopefully
I'm
you can
like,
get caught up next week. I was thinking of taking our time with the next few sections. I might just what's it called?